Hey everyone, and welcome to Security Live. Security Live is a show focused on AWS and AWS security partners, solving challenges for our customers. And you can find us on Twitch, YouTube, and LinkedIn. And every show we bring on an AWS partner and we discuss various topics related to security. My name is Margo, and I am one of your co-hosts. I'm a security and compliance specialist SA with AWS. And Rob?
Hey, good morning, good afternoon, possibly good evening. My name's Rob Hale. I lead AWS's partner security business in EMEA.
And today we have Aqua Security joining us, and we have Tsvi Koren, who is the field CTO from Aqua Security. And Aqua Security is the pioneer in securing AI and containerized cloud-native applications from development to production. And they provide solutions at each of those milestones from multiple milestones through the life cycle. Hey. Welcome. Perhaps you can do a better job than I did there introducing yourself.
Hey, Rob, Margo. Thanks for having me. Glad to be here. So yeah, I'm the field CTO of Aqua, and as you said, Aqua has started around 9 years ago when Docker containers started to emerge in the industry. And our job is to secure them. So we secure containers, cloud-native applications in containers, in functions, in Kubernetes. So if you hear any of these terms and you're wondering how to secure us, probably give Aqua a call.
9 years ago, that feels like a long time ago. It's all changing.
Yeah, honestly, I don't even remember what happened before 9 years ago. But I've been in security for about 25 years now. I started in the tail end of the last millennium. The reason is that I just found a job in a security startup, and I just got into security ever since.
Do you remember we used to say that like servers were like pets, and you give them names? And then I think, well, what was it we used to say about containers? That containers then were like cattle, which if you're vegetarian isn't a great analogy, but there was like this, I do remember this about 10 years ago, this trending in conferences, people talking about your server.
Yeah, absolutely. Yeah, one of the things that's interesting about containers that you really don't manage them individually, right? You manage them in groups, you manage them in deployments, you manage them in scale sets. So unlike the server that was probably in your basement and you gave it a name and you uploaded the software onto it and you manage it over time and patch it over time, containers come and go. And there are some really interesting methods on how to secure them and how to build them securely.
I did have one.
So you feed and water, not necessarily water, but you feed and you look after a server, but containers you must herd. Is that the kind of herding containers? Is that the right terminology?
Yeah, basically, there was a container orchestration. So containers are usually orchestrated, right? You don't just start an individual container unless you're doing some testing. So you would start a whole deployment, and then all the containers should behave the same, and they should all have the same setting, and they can compensate one another. They can grow, they can scale with the application. So the idea is that you are not going to have a single point of failure anywhere in the environment.
I did have a customer once, I remember, and he used to have his chickens on his server in his office. And I thought, well, this is actually a good use case. They really liked how warm it would get, and he actually had nests and chickens sitting on them. Anyway, moving into containers, what recommendations would Aqua Security have for customers who are trying to prime their applications to be defended properly? And of course, we've like advanced now with AI and everything, but I'm sure there are kind of some core best practice and recommendations you guys would recommend.
Yeah, so one thing that's really important to understand is that containers caused a kind of whole strata of IT practice to basically disappear or become minimized, and that's ops. Right. So in the old world, you would design your piece of software. You would say maybe it's a Java application or a .NET application, and then you would ask ops to build you a server. And they would build the operating system. They would put all the necessary components on that server, and then you would put the application on it, and that server would live maybe for a number of years. What happens with containers is that the people that design the application, those that build the application and put the container images that will eventually become live containers, have control over the entire stack, top to bottom, right? So the selection of the operating system, the selection of the base components, what goes into the application, even the base operating system version, are now all part of the application design. So when I talk to my customers, for instance, what I kind of tell them, the way I present that is that, an individual developer really didn't have any knowledge of what version of Bash was running on the server that their application would eventually run on. But now, because there is the component selection and the design of the application is now done when you're building the image, you do care, or at least you have an impact about what version of Bash, what version of the base operating system, what other components of the base operating system are going into the application. And unfortunately, development organizations got basically, that job got thrust upon them, and they were not ready for that, right? Because developers know how to write code, they really don't know how to design the operational status of an application, and that brings some of the security challenges about managing containers, and it also brings the onus on the development teams, the people that build and design applications, to make good selections. So the first thing that I would say is that when you're building an image for containers, the selection of the base image is really crucial. If your application does not need a lot of base operating system services, you might want to use a lean image. There are a lot of vendors, Google, Docker, many images. Alpine is a good distribution for a lean image that don't carry a lot of the superfluous components that you would have for full operating systems. So if you just need to run a small node application, or if your application component only needs to do one thing, just make sure that you don't put a lot of other things in that operating system, because these things can then just sit there and become a target for attackers.
Yeah, this is all about reducing attack surface, which we used to do in server hardening, on a more one-to-one kind of basis, and often you'd have gold images that you'd load up. But when you're talking about containers, you're not talking about 5 or 10 or 20 servers, you're talking about hundreds, possibly thousands of containers. So controlling your attack surface and your vulnerability space really seems like an important thing to get right at the early stages.
Yeah, absolutely. And one thing to remember is that once a container is launched, unlike a server, you're really not supposed to touch it. It really is not supposed to have any interactive access. You're not supposed to log on to a running container, which means that a lot of the software that you would have on it that serves the administrator shouldn't really be there as well, like things like UserAdd, things like the password application, the thing that allows you to change your password. Those really don't need to be in a container, because nobody should be using them. And the only people that might use them are actually attackers that are going to use those in order to further the cause inside of your environment.
So are there tools that help you to view what your images are, so your templates for creating those containers, and then remove those vulnerabilities or those services that are running?
Yeah, so there are basically 4 ways to counter vulnerabilities in containers. Right? The first and basic thing is just not to have any vulnerable components. And of course, the more components you have, just statistically, you will have more chances of having more vulnerable components. The other thing to do is to just keep your components up to date. And again, that is very different from traditional servers, because in traditional servers, you would keep the application in place and you would just patch the operating system around them, like you would do update to your laptop, from time to time, without changing the fundamental software in your laptop. But with containers, you have to build a new image. So when you really don't never patch a container, you would build a new image with updated components, and then you would replace the running container with a new version of the entire container that now has the patched components, and hopefully your application does not persist data in that container, because that is another thing that containers are not supposed to do. And if all that works well, you will now have instantiated a whole slew of new containers that's supposed to do the same thing with updated components. The other 2 ways to deal with vulnerabilities is, first of all, to accept it. And we live in a world where there is no chance to get 0 vulnerabilities anywhere. So the whole idea is to manage vulnerabilities, manage the risk level that the organization or the application can tolerate. So accepting a vulnerability, basically saying that it's okay that it's there. We might have some compensating controls, maybe on the network side, maybe on the runtime side. We can do that. And then the fourth thing, which is where Aqua really comes into play, is we can compensate for vulnerabilities and other risk areas by putting very strict runtime controls over the things that a container can and cannot do, and that will make it so that an attacker will not be able to further their cause inside of the container because they will hit a wall. So reducing the number of containers that the application just uses in general is going to not allow attackers to live off the land, as we call it, but then putting more and more restrictions on what a container is to do and really tailoring it to what the application needs will allow us to run the application safely, even in a high-scale containerized environment.
And I think what you're describing, we often use the term shift left. So you're kind of minting in or pushing in security practices on the left-hand side of the cycle rather than once the containers have moved into production. How are you seeing that evolving now in Aqua Security with the advent of AI? Are you seeing people using AI practices in the left-hand side of their pipelines? Is it impacting the number of vulnerabilities that people are seeing?
Yeah, so AI actually introduces a whole new category of vulnerabilities, right? If the vulnerabilities that when people think about vulnerabilities, it's either CVEs, so common vulnerability exposures, the system that we have to classify bugs in software that have security implications, or it is a vulnerability in the software design, so things like SQL injections and things that might be discovered by a web application firewall. AI brings a whole new set of challenges. It is how the model is resilient to prompt poisoning, how resilient the model is to the feedback loop between the model and the prompt of the users. There's also the selection of the SDK that you're going to use if you're going to have the application call out to an external AI model. So all of these are new components that we are really only seeing in the last year or so. And those have their own set of vulnerabilities that we need to manage and that we need to be aware of as we build our application, if it is an AI-enabled application.
That's really interesting in terms of where customers need to spend their time. So if you had kind of 3 tips for customers who are building or have developers or application owners who are really pushing for containers, what would those kind of 3 tips be in terms of things that to do and things not to do, especially in a world where we have lots of drive for AI and cloud native databases?
Yeah, so the first thing, as we said earlier, is just use the leanest image that you can as your base image. Just do not put any components that really don't need to be there in the file system of your application. This is the one, and the differences are really stark. You can have a bloated image or a full operating system that can have maybe 500, 600 vulnerabilities that you need to manage and account for and be screamed at to fix. But if you use a leader image, if you use, let's say an Alpine image or the UBI, the Universal Basic Image from Red Hat, it really boils down to the single digits, right? So the differences are really, really stark. So the first thing that I would say is use the leanest image that you can. The second thing is, and that's something that not a lot of people are paying attention to, is that images live in a registry. So the way that containers work, you would manufacture an image, you would put it in the registry. It basically waits there until something like Kubernetes is going to make use of the image. And because we are dealing with generations of images that build up the application, because each time we patch or make a change in the application, there's a new image generated. Those registries really become bloated. And we've seen in our customer base that customers have registries where for 2, 3, 5, 6, 7 years, nobody has ever deleted an image. That is also a problem because those get scanned all the time and we get dinged on applications that really are not in use anymore. But also, attackers really love to have Kubernetes go into registries and pull old images and run them because they know that there are more vulnerables, because they know that there's more bugs in them. And because Kubernetes will happily run any image that it has access to, getting images off the registry after a year, after 6 months, right? Don't do it like on a daily basis, but if you have images in your registry that are more than 6 months old, really ask yourself, do they really need to be there?
Yeah, we see that a lot with we see that so much with containers and serverless as well. If you've got legacy containers and legacy, things like Lambda functions, for example, just letting those build up and then you have to try and find out, well, is this actually still in use? How can we track that? Nobody wants to cause any downtime, but also you have vulnerabilities potentially increasing.
Yeah, and then my personal pet peeve is what they call lift and shift, which is, let's take, people want to run things in container. It's easier, you can really run them at scale on AWS and things like the Kubernetes services or in Lambda. And what they do is they take a complete server that maybe have lived for a number of years, take the entire disk, take the entire operating system, and then convert that to an image and try to run that in a container. And this creates a myriad of problems, because it a lot of times it actually forces you to run as a higher privileged user, because on a server, you in order to make use of all the operating system services, you really need to be root. So it kind of pushes you towards giving containers more privileges that they need. But then it also plays into the fact that you will have, 500, 600 vulnerabilities, a lot of superfluous components, a lot of openings for an attacker to, if they get the foothold with a misconfiguration or a vulnerability, or maybe even something that came through the supply chain, right? We've seen instances where components have been poisoned really on GitHub and been pulled in. They now have a complete toolbox that they can use to further a cause into the cloud. Containers kind of self-document, so they will tell you where their control plane is. And if you have all those operating system capabilities, then an attacker can really make use of those and attack your cloud.
Do you find when you're working with customers, as a company, Aqua Security, are you somewhat agnostic if they're using like a managed service, like let's say the managed Elastic Kubernetes service, versus say deploying natively on an EC2 instance? Is there, from a security perspective, do you recommend handing over some of the practices to the cloud service provider in that example? Or is it kind of, are you seeing the same behavior in both cases? Same problem, same.
Yeah, interestingly, right, Aqua actually precedes Kubernetes, right? Kubernetes is about maybe 5-6 years old as an adopted platform for running containers. Aqua has been around since basically Docker started containers in 2015. So we've been through what was called the orchestration wars. So when we started the company and thought of the methods and what we need to do in order to protect containers, the orchestration really wasn't a thing. So Aqua in its core can protect a container wherever. It could be Docker or containerd on a EC2 instance. It can be in the Kubernetes services. It can be in Fargate. It can be in anywhere that containers are running. But over time, we had to get more capabilities that will help you manage the risk of those services, right? Kubernetes itself is first of all, Kubernetes runs in containers, which if you think about it is really meta. And then Kubernetes also has hundreds of configurations that can go wrong. The cloud itself has maybe hundreds of thousands of configurations that could go wrong. So everything we do in Aqua is in the service of the workload, eventually the container. But in order to defend a container, you need to know where it's coming from. You need to know where it is. You need to know what the parameters. You need to know the environment that it operates in. And therefore, we also have the ability to look into Kubernetes, look into the cloud, and find the settings and the things that affect containers so that we can account for them as we do the defense on those containers.
That's so interesting, because from a Kubernetes perspective or a Docker perspective, a lot of those containers are in a server, maybe on-prem, and they get migrated into the cloud. So is there a kind of a recommended way of I guess streamlining that lift and shift so you have security mechanisms in place to reduce the attack surface and the vulnerabilities, and make sure you're looking at permissions as they migrate to the cloud? So kind of a model to stop you just lifting and shifting to get the job done.
Yeah. So if lift and shift is taking a complete server, right, a monolithic old style server, and turning it into a container image, once you've turned that into a container image, and I would urge everybody to kind of look at the application and re-architect it so you don't pull it completely into an image. But once you have a container image, the nice thing about it is it contains all its dependencies, so it can run anywhere. So you can actually safely take a container image and run it, on a Docker server on your desk, and then migrate it into EKS, and then migrate it into Fargate, and it's going to operate in the exact same way. However, in each one of those environments, the container might have different properties and different access that it is going to inherit from the orchestration. So for instance, when you run a container in Kubernetes, and if people have access to containers, just do a dump of the environment variables. And you will see, the IP address of the Kubernetes API server, basically the management plane. You will see the cloud labels. You will sometimes see cloud information. So those get inherited by the orchestration system. And when we look at how to defend containers, we also need to defend against attackers using that metadata that is just readily available to be read in a container in order to affect the orchestration system around it. So there's nothing wrong in taking a well-built container image and moving into the cloud, but just be aware that as you do that, the container might inherit more information, and we just got to be aware that that information is there, and it's really not protected as long as somebody has access to that container.
Great tips there. Great tips.
I loved your phrase there, orchestration wars. I actually hadn't heard that before, and I didn't realize Aqua Security was around longer than Kubernetes, which is actually pretty cool. Do you think people introduce unnecessary complexity? I mean, I sometimes amusingly feel when I'm talking to customers, they describe an application, and rather than describing the business capability, they go, and we want to use Kubernetes. Is there unnecessary complexity that sometimes is brought in when they're trying to re-architect, and how can that be avoided?
Yeah, so not every application should run in containers. We're seeing in our customer base, we're seeing kind of hybrid applications where there could be a kind of high capacity short transaction that might run in Lambda. It might transact versus a set of deployments that run in EKS that doesn't need to persist data, but need to persist transactions. But then those will talk to maybe applications that run on EC2, which then persist data into either cloud storage or locally. So my advice would be, just instead of determining in advance how you're going to run the application, look at what the application needs. If this is a high capacity short transaction application, maybe function is what you want to do. If this is a application that need to persist data, let's say you run an FTP server, for old timers, or something that needs to store files, a container is not a good use case for that, because containers are, Kubernetes, once it moves the container from one place to the other, it might lose the storage of the container unless you're using an external storage. So when you architect an application, think of yourself, what is the flow of the data? What needs to be persisted? What is the length of the transaction? How long do we need to sustain a transaction? And then you'll kind of get an idea of what is the right deployment mode for that component of the application. And applications, complete applications, end-to-end applications, could have certain modules that run in EC2 instances. They might have modules that run in EKS, and they might have modules that run in Lambda.
Just a quick reminder: if anyone's has questions on container security, pop them in the chat, and we can ask them live and discuss them.
And there's also been a QR code flashing up. Here we go, which I believe Tsvi is linked to an Aqua Security tutorial.
Yeah, it's linked into our information page about running generative AI safely in containers. But on the Aqua website, once you get there, we have our container wiki, which is a good source of information for containers and best practices. You have access to our knowledge base around how to safely run containers. And there are links there to various resources if you want to learn more about how to run containers safely or the capabilities of Aqua.
What do you think containers will look like 5 years from now? We've talked about the past. We talked about the orchestration wars, which sounds like a George or Martin book, by the way. We've talked about Aqua Security being around longer than Kubernetes, which I love. What do you think the next 5 years might look like?
So containers are now the primary vehicle to run AI-enabled applications and AI models. As organizations start to look into implementing their own on-prem, which doesn't mean in their building, but under their control, AI models for their own uses, the use of containers is only going to grow. Now, I've been long enough, even from the mainframe days and back in the 90s, people were telling us that mainframes are going to disappear. That hasn't happened, right? They have very, very long tail. I think containers are going to be there in 5 years. They're probably going to be orchestrated by AI-capable orchestration, which is going to be even more intelligent at what Kubernetes can provide. Hopefully, we will have a much better handle on the vulnerabilities in containers, but containers are not going away. They are now the primary vehicle to build applications, and I expect that to stay the course for at least a number of years.
I love your use there of the phrase on-premise. It's the first time I've heard it used, but you used it in the context of somebody actually, running their own model or doing their own training in a container, maybe in the cloud, but it's like this on-premise notion, we're doing it ourselves. Is that what you meant? Did I pick you up correctly?
Yeah, on-prem can mean different things, but it really means under your control, right? So it could be your application can refer to ChatGPT or Llama as an AI model. You can run a local copy of that. You can run a local copy of that in your own AWS account, or you can own the copy in your own data center. But the container is going to be the same container. It needs to be defended the same way.
Yeah, we have a similar model in terms of we bring the model to the customer in AWS services like Bedrock, for example. So we bring that into your environment and then allow that to access data, etc., rather than sending data to the model. That seems a poor security and governance model of operation.
Yeah, absolutely.
Well, I think this has been super interesting. Will you be at Reinforce, which is happening next week? Yes, next week, I believe. Any chance we get you over there?
I'm not sure that Aqua is going to have a presence in Reinforce, but we are always happy to engage with people that run services in AWS, and you can always contact Aqua if you have a need in that respect.
Awesome. Tsvi, it's been awesome to have you. Thank you so much for your time. Really, really great to hear about the things happening in containers and security and how our customers can start to implement better security and more governance around that. So thank you very much.